I started doing NDT within NDT industry in 1987. So I have now got over 35 years of experience in the industry. I began in 1987 and went to, after leaving the Army, I came to the College of Oceaneering, and that's where I went into commercial diving. And but I took the NDT as a backup in case commercial diving didn't work out. And then I just took a hold of the industry and really enjoyed doing inspection. So I ended up in inspection first and later turned that into a job with a diving company. But I've been involved with ASNT since 1990. I got my first ASNT level 3 in 1992. Received my CWI, which is Certified Welding Inspector from American Welding Society in 1996, and obtained other certifications along the way. But I've been involved with the 94 earthquake, one of the natural disasters in 1994. I've had some really nice landmark projects. I've worked on the Las Vegas High Roller and the San Francisco Bay Bridge, replacement bridge, and worked on the large ring on the SoFi Stadium in Los Angeles. With ASNT, I've been involved as a section leader, a regional director. I'm involved with many of the technical committees, and I've been the president and chairman of ASNT. And now I'm on my second time on the board currently. I've been very fortunate in my career. I've worked in virtually every industry. I've worked in oil and gas. I've worked in marine. I've worked in amusement parks, large construction projects. So I've had a really diverse background, which I've been very fortunate to have.
Can you tell me a little bit about what ASNT does and how it fits within the infrastructure industry? And what is the role of the director at large there that you have?
Okay, so ASNT has been around since 1941. It began as the American Industrial Radium and X-ray Society. It started in Boston during World War II. So ASNT basically provides certification, education, career development through publication, references, archives, training, and conferences for the practitioner, engineer, and researcher. So we cover the full spectrum of the industry, and we work and collaborate with other professional societies like ASCE and ASME, AWS, in order to improve and enhance NDT for different industries. As the director in large, basically we serve as the fiduciaries for the society, and we represent our membership. Our current membership, I think, is around 13,000. So we represent the NDT industry both nationally and internationally. We have people that sit on ISO committees, and so we are involved with all that, and setting up conferences and picking out solutions. And we're now working on different committees to improve our advocacy and other things like that. And we set up the strategic plan for the society. We usually do a 5-year plan, and we try to set that up for the society. So we keep moving in the right direction.
So what does FlawTech America do, and what is your role there?
FlawTech America is the world leader in one of the world leaders in flaw manufacturing technology. I'm currently the president there. So we have a unique thing. We actually put flaws in things on purpose, which is a little different than what the most inspection people do. We actually look for the flaws, but we put them on purpose to either train personnel, do performance demonstrations, or actually we're also involved with research and development for new techniques and technologies. We also provide specimens to the manufacturers of equipment so they can do their demos and things like that. So we're involved with the training and education a lot in the NDT world.
Can you quickly describe how you put a flaw into something, and what's the process behind that?
Most of our flaws we put in during the welding process. Our welders are actually very good welders. I mean, anybody can make a bad weld. This is easy, but the hard part is to make the flaws be at the right location and the right lengths and dimensions, because that's what's important when you test the inspectors. You have to give them you have to have a known length, or you won't know what to grade them on. It's kind of a trade secret how we do some of the stuff. A lot of stuff we make are real. So it's like if we are welding, we'll put in slag, or we'll put in actual lack of fusions, where lack of fusion is where there's a gap where the weld doesn't fuse. And we have a method of putting those in so that they, and it can be anywhere in the weld. We can tilt and skew them. And let's see what else. but it's I can't really tell you exactly how we do it, but it's both a mechanical and sometimes we use other methods to and manually to put them in and make them look like the real flaws.
So please describe the field of non-destructive testing and how it uses technology to achieve its goals.
Well, the field of technology started out really simple back in, like, I don't know, it's predates 1878, but the first reported one I could find was actually oil and whiting on the railroad, and that was in 1878. And it was also used in 1893 by George Washington Gale Ferris on the world's largest Ferris wheel at the time at the Chicago World's Fair. And he was actually a bridge engineer, so that actually ties into our infrastructure thing as well. So that's basically the background. ASNT started in 1941, basically as radiation and X-ray. That was a big moving thing in 1941. But basically the technology moves along. If you think of like a cell phone and how those started and the size of those things were when you first got them, now what we have, the technology. So when I got in 87, there was no digital equipment whatsoever. It's all analog. So as we've moved forward, moved to 2000, fast forward, we're using completely digital equipment. We're collecting lots of data, and as we keep moving forward, we move it forward just like all the other technology, computer-based data. We used to collect data in megabytes. Now we collect data in terabytes, which all this data can be brought into to play and provide the engineer a lot of information to just make decisions on what we find. So either it's good and keep going, or it has to be repaired. But we have over 12 different methods of NDT, which includes ultrasonics, eddy current, visual, radiation. There's 3 different types. There's X-ray, there's GPR, and there's several others, infrared. So there's lots of different technologies that we use, and we have a large base of information, and we have a large group of vendors and manufacturers that support the industry with advancements all the time. Some of the technology, we use some of the same technology that's used in medical. The ultrasound is very familiar with a lot of people, and we also use the iridium X-rays. So sometimes we can steal stuff from them, or sometimes they get some technology from us. So in the industrial side. NDT is basically the inspection, well, the testing or inspection. There's also NDT, NDI, NDE. They're all pretty much self-related, but different industries use the terms differently. But basically, it's inspecting or testing a part, a component, or a material to verify its characteristics, to look for anomalies, and to validate those towards a specific code or specification and after you're finished inspecting, they're still serviceable and can be used. So there's no destruction to the part, no harm to the part.
How is non-destructive testing used after a natural disaster such as Hurricane Ian? Which types of infrastructure inspection need to be performed, and why?
Usually the first thing that happens after the natural disaster is it's the most common used non-destructive testing is visual. Typically a group of, in Los Angeles, they have a group of people that are designated as emergency response groups of people. There's different NDT service companies, different engineering companies that are involved. And typically first what happens is they clear all the means of egress, emergency egress back and forth, so that they can get all the emergency vehicles and all the responders in and out and get the rescue people out. So the first things are going to be inspected are the bridges and other thoroughfares for verification that they're still stable. During a hurricane type thing like Ian, you've got to look for, because of the water surge and things like that, you end up with sometimes a scour or other things that affect the bridges that remove the support. And so that's one of the things you look for. And what's really nice now, we are actually using a lot of, another new technology, we're using a lot of UAVs now as well. So UAVs allow people to get into those areas and see what those conditions are a lot easier than they could before. But next usually is the hospitals and schools and any of those places that are used for helping those people that are in that situation. And those are also the areas that are usually used for people to congregate and to seek refuge from those areas. So those are usually that. Then later it keeps moving out from commercial buildings and it goes out to residential. And but usually what happens is the engineers identify areas that they're concerned, and then they will bring in to do either ultrasonics usually or mag particle to determine if there's any fractures or cracks or any kind of damage that they need to know about that they could not see themselves from their visual observations.
Okay.
It continues then, they'll bring in another group of people and they'll start doing the residential inspections and things like that too. That's usually a different group of inspections. That's not much, there's really not much NDT usually in the residential, but they still have to go in and evaluate that. And as it continues, they'll evaluate buildings and stuff as they do the demos as well to make sure they're where they should start and how the procedure should go to take the buildings down if they have to.
All right. So from your experience, what might be some best practices for disaster infrastructure inspection that maybe not every inspector out there is doing?
I think the best practice is being educated in the structures that you're inspecting first. That's the best practice, is to understand the failure mechanisms that occur during that type of event. And usually we, as the inspector, we usually get a lot of those leads from the engineer. He'll tell us what loads he's concerned about, where he's concerned about, and we're kind of directed in where we're supposed to look. We're also encouraged to look other places too as well while we're doing the evaluation. During the 94 earthquake, there are telltale signs of damage to structures. You'll see dropouts in concrete. You'll see for fireproofing on buildings, you'll see a crack in the fireproofing that may lead to, or you may see coating crack that may give you an indication. Of course, if you may see buildings leaning, you may see different things happening that lead you to go look there. So it's best to work with a group of people that have experience with it the first time. Going in there the first time would be very, very difficult. You would not know what you're looking for.
So what advice can you give our engineering audience about non-destructive testing and inspection that they can use in their jobs and designs, even if they're not inspectors?
I think a lot of engineers know some about NDT, but NDT helps validate that the production and the fabrication that they've designed for is conducted, and they get the welding and the connections that they need. So it ensures the quality of that project, and that structure or whatever component is going to operate and survive and last as long as it can. Like if a bridge is made to last 50 years and the welding is not done properly or the coating is not done properly or any of that, then that 50-year lifespan just got less. So and it also ensures the safety of everybody that works or stays in a particular asset. Amusement park rides and buildings need to survive during certain conditions. And that gives the engineer assurances that his design has been completed properly. But the engineers, a lot of times, if they can they incorporate or use, and if they have a good knowledge of NDT, then they can go right ahead and spec it out themselves. But if they're going to spec out some kind of NDT or stuff, it's probably good to get a subject matter expert in NDT to help them develop their inspection testing plans for their particular project.
How might they use some of your advice to prepare their infrastructure so it's more resilient to natural disasters?
The biggest thing is ensuring the weld quality is what they intended it to be. I mean, knowing that those connections and those joints and everything is going to respond and react and to the tension, that we don't really design those and design the assets. I mean, the engineers do, but that's just using the right inspection testing plan is what helps the engineer, and that what helps extend the life of the particular asset. I just think NDT is one of the unknown professions out there, and I think it's a great opportunity. Anybody that has a knack for having some curiosity and likes to look for things.